using prime factorization will actually be beneficial to what we're going to do today. So let's at least try number 3 here, 45. Prime factorization is when you break it down to where all you have left are prime factors. So 45 we could say is 9 times 5. 5 is prime. Now we got to work on the 9. 9 is 3 times 3. And that is all prime, so we have all of our prime factors. So we write it as 3 to the second power times 5. So we're going to get into fractions, and when you're adding and subtracting fractions, they have to have the same denominator. So we're going to be looking for what's the smallest number we can have as the denominator, which is called the least common multiple or the lowest common multiple. So a multiple is a number that is the product of that number and any non-zero whole number. That's very formal. But look at multiples of 4. So it's like counting by 4s essentially. 4, 8, 12, 16, 20. Goes on forever. Multiples of 6, you're counting by 6. So they have the smallest number that they have in common that they're both multiples of would be 12. But they also share 24, 36, 48, 60. But you're usually looking for the least or lowest common multiple. I usually call it the lowest common multiple. You see here it says the least common multiple. It's all the same. So find the lowest common multiple of 12 and 40. So this is where I like the prime factorization idea. So what I would suggest is, just like we did with the greatest common factor, we're going to break it down. And we don't need to necessarily break it down to just the prime numbers. I would say try to find the largest number you can that goes into both of them. So like 12 and 40 have a 4 in common, 4 times 3, and then 4 times 10. So they have a 4 in common. So just like with the greatest common factor, we brought it down. Then you look at what's left. 3 and 10 have nothing in common. So 4 would have been the greatest common factor. But for the lowest common multiple, once you find all the things they have in common, then you bring down all the leftovers. So we bring down the 3, and we bring down the 10, and we just multiply them all. So 4 times 3 is 12, times 10 is 120. So 120 is the smallest number that 12 and 40 can go into. Let's try it again. 6 and 16, what do they have in common? They're both even, so I know that 2 goes into them. 6 is 2 times 3. 16 is 2 times 8. They have the 2 in common, bring it on down. Now, do 3 and 8 have anything in common? No. So 2 would be the greatest common factor, but we're looking for the least common multiple. So then we just bring down all the leftovers. Times 3 times 8. 2 times 3 is 6. Times 8 is 48. It's not bad, right? 9 and 15, what do they have in common? A 3. 3 times 3, 3 times 5. They got 3 in common, and that's the greatest common factor because 3 and 5 don't have anything in common. So then we just bring down the leftovers. Times 3 times 5. 3 times 3 is 9, times 5 is 45. Now, 12, 15, and 18, I know that you could say 6 goes into 12 and 18, but first you have to look for what goes into all 3 of them. Then you can start looking at pairs. But all 3 of them have 3 as a multiple. 3 times 4, 3 times 5, 3 times 6. They all have a 3, so we'll just bring it down. Now 4, 5, and 6 don't all have something in common, but 4 and 6 have something in common. They have a 2. So we could say this is 2 times 2, and this is 2 times 3. We bring down a 2, and then we look at what's left. Do 2 and 5 have anything in common? No. Do 2 and 3 have anything in common? No. Do 5 and 3 have anything in common? No. So we've taken every possible common factor with every set out. So then we just bring down the leftovers. Times 2, times 5, times 3. Now remember, your commutative property and associative property, but this would be the commutative property. It doesn't matter the order that you multiply in, go with what's going to be easiest for you. So let's say we did 3 times 3 is 9. We have 2 times 5 is 10. And then we have a leftover 2. So 9 times 2 is 18, times 10 is 180. That is the smallest number that 12, 15, and 18 all go into. Phew, that was almost too much fun. Now we're going to bring in variables. Same idea first. Let's handle the numbers, 6 and 18. I know that they have 6 in common, so this is 6 times 1, this is 6 times 3. They have a 6, bring it down. Now we have 1 and 3. I mean, we can ignore the 1 essentially. So then we just have to bring down our 3. 6 times 3 is 18, which makes sense because 6 goes into 18. So when we did the greatest common factor, we had to go with the lower exponent on the variable. When we're going least common multiple, we go to the top. We go to the highest one. So we would say a to the third. This would be your least common multiple. Now, if I said, well, what's the greatest common factor? They both had a 6 in common. So GCF would be 6, and then they have at least a to the second power. So I know it can be a little confusing. Greatest common factor, you find that first anyway, and then you just bring down the leftovers for the 18, and then greatest common factor, we went with the lower exponent, and the least common multiple, you go with the higher exponent. You'll get used to it once you do a few of them. So we're going top dog on the exponents. So we can handle the exponents now. It's going to have x to the first power and y to the first power. Let's handle the exponents on b. You go the highest one, so it'd be m to the fourth. And then on c, it's going to have an x and a y to the second. Top dogs on everything. Now let's figure out what numbers are going to go in front of it, what coefficients we're going to have. So 12 and 15 have 3 in common. Have the 3, great. 4 and 5 have nothing in common, so just bring them on down. 4 times 5 is 20, times 3 is 60. So our least common multiple would be 60xy. Over here, 8 and 14 have a 2 in common. 2 times 4, 2 times 7. We got the 2, bring it on down. 4 and 7, nothing in common except for 1, so we just bring it down. 2 times 4 is 8, times 7 is 56. Excellent. So much fun. 25 and 15, they got a 5 in common. So we bring it down. 5 and 3 don't have anything in common, so just bring those down. 5 times 5 is 25, times 3, 3/4 is 75 cents. 75x, y, squared. Pew! Oh yeah, fractions and decimals. A customer at a delicatessen asks for 3/4 pound of potato salad. The scale reads 0.75. Is the customer getting the amount of potato salad she requested? Explain. Calculator, very beneficial for this section. So let's say all you gotta do is 3 divided by 4. 3/4, and it comes out to 0.75. Yes, because 3/4 equals 0.75. So write each fraction or mixed number as a decimal. You just pop them in your calculator. 1 divided by 4 equals 0.25. Now, if you're plugging in B in your calculator, it might be kind of weird. Some calculators, that's easy to format in there, but really, just do 7 divided by 8, whatever that is, and then put a 1 in front of the decimal since you have a 1 out there. So let's see what 7/8 is. Oops, that's 7. 7/8, 8.875. So this would be 1.875. 3 and 3/10. Well, 3/10. Think of that as a decimal when you had to remember the columns of decimals. Tenths is the first one, so it'd be 0.3. And then you have the big boy 3 in the front, so it'd be 3.3. And then if you do 3 divided by 5 in your calculator, it'll tell you 0.6. Not bad. Repeating decimals are those ones you see them in your calculator all the time. You type them in, and it'll be like 0.333333333. Or if you had 0.6, yeah, let's go with A here. So if you do 2/3 in your calculator, 2 divided by 3, you'll probably see a bunch of 6s, and then your calculator might give you that last digit as a 7. That's because your calculator is rounding the last digit. So it really is 0.6 repeating. And the way you write that is you put a bar over the digit that repeats. So this is saying 0.6 on forever. If you did, what's the next one here? 15/11ths? 15 divided by 15, 11, 1.36363636, and then my calculator has a 4 at the end, but again, ignore that, that's rounding. So we're going to say 1.36, and the 36 repeats, right? So you just put a bar over everything that repeats. State the block of digits that repeats. 6, 36. All right, write each fraction as a decimal. State whether the decimal is terminating or repeating. If it ends, it terminates. It's the terminator. If it goes on forever, obviously it's repeating. So 7/9, you'll see a bunch of 7s and then maybe some rounding. So this is a repeating decimal. We'll write R. And the way we're going to write that is 0.7 with the bar over it. Anytime you have something over 9, it's just going to be whatever the numerator is with a bar over it. 21/22. 0.954. Now the 5 and the 4 keep repeating. It says 0.9545455. So you only put the bar over the repeating decimals. The 9's not repeating, but the 54R. So that is a repeating decimal. 11/8 is 1.375. So it ends right there. So it's a terminating decimal. 1.375. 8/11ths. 8 divided by 11. 0.72727272. The 7 and the 2 repeat. Repeating. So again, put the bar over the number that's repeating. Now we're going to get the decimal, and we have to convert that into a fraction. So this is where actually knowing your decimal columns comes in handy. So like you have the ones, then your decimal, and then it's the tenths, sorry. Then it's the hundredths, then the thousandths, then the 10,000ths. So this goes to the second column, which means it goes to the hundredths. So the way we're going to write that is 1 and 12 100ths, right? Because the 1's in front of the decimal, so you can just use it as a mixed number. 1 and 12 100ths. Then, thank goodness we started practicing simplifying stuff. What goes into 12 and 100 would be like 4. So 4 goes into 12 3 times, 4 goes into 125 times. You can't simplify 3/25 anymore, so that would be your final answer. So put it as a fraction over the column place. So like anytime it goes to the second column, it would be hundredths. If it went to the third column, it would be over 1,000. If it just goes to the first column, you could just make it over 10. So 1.75 would be 1 and 75 100ths. And we'll reduce all these in a minute. 2.32 would be 2 and 32 100ths. 0.65 is just 65 100ths. All right, 75 and 100. Think of quarters. There's 3 quarters and 75 cents. There's 4 quarters and $1. 1 and 3/4. 32 and 100, they're both even, sure, so we can cut them in half. But I know that 4 goes into 32, so we can divide them both by 4. 32 divided by 4 is 8. 100 divided by 4 is 25. 65 and 100, I know they're both divisible by 5 at least. 5 goes into 65 13 times, and 100 20 times. There's one more kind of problem you have to do, and it's converting those repeating decimals into fractions. So there's a very formal way to do these problems, very formal. But let me give you a little hint. If you have 0.3 repeating, so usually if it was just 0.3, you'd make that 3 over 10 because it's in the tenths column. So if you have just one digit that's repeating right after the decimal, you're just going to put that digit over a 9. Okay? So if it didn't have the repeat, you put it over 10. Now you're going to put it as 9s. And then you simplify this. 3 9ths would be 1/3. And if you do 1/3 in your calculator, it'll give you 0.3 repeating. So if it's one digit that repeats right after the decimal, put it over 9. If it's 2 digits like this 0.72, you're going to put it over 99. And if it's 3 digits, you're going to do 999. 4, 999. 999. Okay? So 72 and 99 have a 3 in common, I know that. 72 divided by 3 is 24. And 99 divided by 3 is 33. And you're like, oh, well, 3 still goes into both of these. 3 goes into 24 8 times. 3 goes into 33 11 times. So 8/11ths would be our final answer. You should check it in your calculator, 8 divided by 11, and make sure it comes out to 0.72. We had that problem earlier when we were just writing the repeating decimals. 0.7, one digit right after the decimal that repeats, so we put it over 9. Can't simplify 7 9ths anymore. 2 digits that repeat, you put it over 99. These are both divisible by 3. Actually, they're both divisible by 9 too. So 9 goes into 54 6 times, 9 goes into 99 11 times. This one has 3 digits that repeat, so we're going to put it over 999. 999. 1 plus 2 is 3, plus 3 is 6. 3 goes into 6. So I know that these are both divisible by 3. Just for time's sake, well, 21 is 7, 3 is 1. So 71, 999 divided by 3 would be 333. I mean, it's almost too much fun. I don't want to scare you. We'll have more fun this year, but that was almost too much fun.